Can you see my screen?
Yes, go ahead, please.
Okay. I'm happy to share with you our project. We want to use time series analysis and regression analysis to detect COVID-19's impact on crude oil. And we know that it has been 11 months since China reported this virus to WHO, and it has caused 1.25 million people dead until November 6th. And crude oil, it is a very important material. It has close connection with our lives. It can not only be used as fuels for plane, cars, ships, it can also be used as materials of fabrics, tapes, or glues. And I want to talk about our data. Our data was collected from 8 sources, include positive increase of COVID-19, crude oil production, demand, oil import, oil export, and oil price of WTI and Brent crude oil and volatility of WTI price. The procedure, we have 6 steps in total from data preprocessing to our conclusion. For data preprocessing, firstly, we imported our dataset properly and dealing with the missing values. You can see from here that there are not so many missing values, so we just delete the rows with them. And for daily positive increase, for this feature, it will be used as an independent variable. So we set a requirement that its value has to be greater than 0. And you can see every feature is a time series data. So we define the data type of date time on the date column. For data visualizations, we made some plots to compare the tendency of those features before and after the COVID-19 outburst. You can see this is, there are WTI price after and before and Brent oil price, and their tendency are similar to each other. And here are production and demand. Their tendency are similar too, both after and before. And this is volatility of WTI price. And here are oil export and oil import. And then we apply time series forecasting here. We chose the seasonality as year because we take volatility as an example. You can see the seasonal pattern is similar.
Hopper, I have a comment. I know you use very good visualizations, but keep in mind here our data set is very small because of education. But in real case, you should do everything in PySpark. So I don't say delete this visualization. These are good things. But because of the big data course, please do your visualization in PySpark environment.
Yes, we use the Python code in PySpark.
Yeah, I know. But if you have visualization should, I appreciate this visualization, but I want to see visualizations from PySpark, not Tableau or Excel.
Okay, thank
you. There is 2 ways. You can either use some Python packages for visualization in PySpark. Also, but I know there is some limitation. PySpark is developing. There is not that much of, not all of the packages. You can use the Databricks for visualization. In one of your classes, I teach how to use Databricks, but you can use Python packages too. Okay, go ahead, please.
Okay. And after time series forecasting, we also made some plots. You can see the right line here represents a true tendency, and the blue line here represents predicted tendency. And we can see that WTI price and Brent oil price and volatility, they have the biggest difference with predicted tendency. And the statistics proved my idea. We used mean absolute percentage error to evaluate. If we compare the MAPE to the general range of the features, we found that the model performs not so good on volatility, WTI price, and Brent oil price. So we have a conclusion that COVID-19 has impact on those three features. Then we did regression analysis to detect what kinds of impact it have. For linear model, we have GLM, and for nonlinear model, we have random forest, gradient boost, XG boost, and cubic polynomial regression. And let's see GLM first. An advantage of GLM is it allows for more kinds of distribution of the dependent variable. You can see for WTI, the top model is gamma, and for Brent is inverse Gaussian, and for volatility is Gaussian. And here's the statistics. We can see the RMSE is not so good actually. And have a look at the coefficient. We know the positive increase of COVID-19 is negatively related with those three features. We also made the regression line plots. In the graph, you can see there are serious overfitting problems. So we think GLM is not a good model for this analysis.
Okay, go to that overfitting figure, please. Okay, so how you understand GLM has overfitting? Could you explain that?
Yeah, because the package we use is stats model. It don't have cross-validation functions, but we can see from the graph that you can see the residuals has a big difference.
So my question, I cannot see your X and Y over there. What is your X here?
The X is positive increase.
Is positive increase. What is your Y variable?
Is Brent oil price, WTI price, and volatility.
So again, what does positive increase? It means COVID?
Yes, the positive increase every day.
So you know there is no. I'm not sure why you are saying overfitting. What I can see here, there is no linear relationship.
Yes.
I mean, overfitting. You know, look at that blue line. There is a very small curvature. If it was a very complex curvature, like too much of going up and down, similar to your red dots, you can say overfitting. At least, okay. So here you can say there is no linear relationship.
Okay. Can I say is that the interpretability of linear model to this analysis is not?
Yeah, you can. Good. Yeah, you can say something similar. Okay. No worries. I mean, go ahead.
Okay. Then we use random forest, and statistics shows that it performs much better, especially for volatility. It has an R-square of 0.64. And
yeah, as you said, these are evidence of saying that the relationship is not linear. But okay, go ahead. No worries.
Yes. And overfitting problems are there. And then we tried gradient boost. It performs better than the random forest for WPI and Brent oil price. But for volatility, the performance got a little bit worse. But when we look at, yeah, any question? Okay, when we see the cross-validation score, The overfitting problem is still there, but they are improved. So we think for volatility, gradient boost regression performs better than random forest. And for XG boost, it performs worse than the former two models. You can
Yeah,
see
when there is a high variation in your faults, it could be an evidence for overfitting. Okay, go ahead.
Okay, and for polynomial regression, I don't want to talk too much about it. It's even worse than XG boost. So after the final model, we find gradient boost regression is the best model. But there's still overfitting problems, and R square is not so high, so we made some improvement. For independent variable, the positive increase, we use the trending, and for the dependent variable, we delete the outliers and normalize the distribution. And let's see the trending. We plot the autocorrelation of the independent variable. You can see it is decreasing gradually, which means it's not good. Also means that our independent variable is non-stationary. So what we do to make it stationary is detrending. We have two metrics. In the first step, we detrending it by subtracting the least square feet and this plot of it. In the second step, we detrending by subtracting the trend component, and it becomes this. We also made plot of autocorrelation after those two steps. We found it becomes much better. But in the final step, we found some mistakes that the detrended variable has many missing values here. And we searched online. It says the data volume is not enough for 2 complete cycles in detrending by subtracting the trend component. Indeed, we only have data of 11 months, and we can do something about it. So what we do is use the detrended variable after step 1 as the independent variable. But it can be interpreted by gradient boost. You can see the R square is negative. We also made scatter plot. You can see it's such a mess. So this improvement failed. Then we deleted, we deleted the outliers. We use the box plot to visualize outliers. You can see there are a lot of outliers in WTI and volatility. So what we do is delete the outliers in them. After that, we apply gradient boost again and see the results. The performance of it on WPI got better, but the performance on volatility got worse. So our decision is to delete the outliers in WTI and leave the outliers in volatility. And the final improvement is to normalize the distribution.
Could you go back, please?
Okay.
2 slides. Okay, to one of their faults, yeah. So what you put here, I mean, I see there's a title, 5-fold cross-validation, and inside that we have -12, -16. What are these?
Minus score.
I mean, what is it? Is it like, I mean, it's not variance for sure, and it's not accuracy. I just want to see what you put in each cell, what each value means.
We just use a function cross-validation score, and we got those numbers.
Okay, so please search what does those scores mean. So when you want to report it, don't leave any table empty, I mean, without the
Okay,
explanation.
okay, I'm sorry.
So no, that's fine. So when you report it, explain what is inside each table. So if somebody doesn't have that background, when they read the variable, the numbers, they can understand what does it mean. Okay, never mind, go ahead.
Okay, and for regression problem, they usually have requirements for the distribution of dependent variable as normal distribution. So we can see the volatility distribution over time is like a right screwed distribution. So we use the metric to transform it to normal distribution by change the values to their logarithms. This is a metric. And for another two dependent variable, WTI and Brent oil price, at the first glance, we can't figure out what kind of distribution they are. But if we can flip vertically of those tendency, it became right screwed distribution. So we make some changes on it. First, we made all the values to negative by minus a number greater than their upper range. That is for WTI, we minus 65, and for Brent oil price, we minus 75. And in step 2, we transform all the values to their absolute value. In this step, we flip tendency vertically. Like this. Now it's follow the right screw distribution. And in the step 3, we take their logarithms and they become normal. And after that step, we applied gradient boost again. You can see the result is much better. First, the R square score got much more higher, especially for volatility. And the overfitting problems is a pity that it still exists, but they are very improved, especially for volatility. You can see the score is from negative 0.14 to negative 9.12. It is that much. 19 has low impact on demand, production, quantity of import and export, but high impact on price, whether WTI or Brent crude oil price. And after the regression analysis, we improved the model accuracy to about 80% to approve our conclusion. And, because oil prices have important impact on economy, not only in the US, they have other relationship with our life, like the creation of jobs and investment. So, and there are two limitations in our work. The first is the multiple data source. It caused inconsistency in our data set. Because initially we want to do multiple regression. Because the demand, production, COVID-19 has low impact on them, so we want to use them as independent variable. But they are collected monthly or weekly. But data of WTI and Brent oil price, they are counted in days, so we can't just merge them together. That's one limitation. Another one is a low data volume. This is the reason why improvement 3, detrending, is failed. I think with more data available in the future, we will try to reduce the detrending. Okay, thank you, everyone.
Okay, go back, please.
Okay.
One slide.
Which one?
I mean, not your last slide, one slide before the last slide. Okay, you said some data sets like import, demand, or collected monthly, weekly, and Brent prices are counted in day. So what we can do, regression one by one rather than, I mean, you still can do multiple regression. What can you do? Basically, you have two ways. If you want, if your unit is day and you have the monthly price, you can use it for, you can impute it for all the years, all the days of a month. Or if you have weekly, for each day of a week, you can impute and put it the weekly price as a whole of the, as each day price. The other approach, you make a monthly or weekly average. So in that case, you can do multiple regression. I mean, you don't have time to do that for this project, but just for your information, you can change your unit and you can impute, either do the average or impute for all the smallest time units. That's one thing. Also, I want you guys have visualization in PySpark environment, not other environment, which hopefully you did. And the last, and also the most important thing, don't leave the tables without explanation. If there is a number in the table, you should exactly say what do they mean. For example, those cross-validation, what does negative means there? And you should clearly explain each table. But other than that, these really good project. I really like your project.
I'm so I'm just worried about time, so some numbers.
At least, I mean, two things that you should do. You know, you don't have to do multiple regression, so you can forget that. But probably don't have enough time. But for visualization and also explaining the tables, you should do that. This is very important, because if you say -9, what is it? If it's not accuracy, it's not RMSE or R score, whatever. What are you showing there? You should for example, you have R squared. Okay, that's clear. So if somebody see the upper table, they can understand the R score, what those number means, and also which one is a better fit. For example, I cannot read volatility, whatever. So it's better because the R square is 0.79. WTI is the worst because it's 0.61. So anyway, at least do this too, because your due date is September 2nd. So you have like 2 or 3 days to make it. And I think 2 or 3 days is enough.
Okay.
Okay, very good.
Thank
but
you.
good, but generally good, very good research, and is very relevant to these days. Anyway, thank you very much. Is there any questions from other people? Okay, so if there is no question, that's for it. Thank you very much. We had a really good semester. For the people who are in the business analytics visualizations, you have your final exam. I posted tomorrow. You probably have a couple of days to answer it. For people in the big data analytics, no, Wednesday, I don't think, there is no class on Wednesday for sure, and I'm not sure if I am available, but you can just post your video. The reason people present sooner, they have an advantage because I can give them comment and they can fix it. But if you want to present on Wednesdays after due date, so there's not that much of point if you present, because I cannot, even if I give you feedback, is after due date. But anyway, if you want to present to me, that's another story. Okay, anyway, thank you very much. I had a really good semester with you guys. Hopefully, I see you next semester in person. Okay, go ahead, Jimmy.
I have a question about our presentation. If we have present in class, should we submit the video as well?
No, you don't have to. I will upload your video on Moodle.
Gotcha. Thank you.
Thank you very much.
Thank you so much, Professor.
Thank you. Hopefully see you guys in person next semester. We are bored up. It's so boring. I mean, hopefully we get rid of the virus soon. Thank you very much and have a great evening.
You too. Take care.
Bye.